This will be another video about block event chaotic pulse technology. It will continue on from my previous video called a random video about block events. So if you want to understand this, I would recommend watching this video, but you might also be able to understand it without that video. Now, on that previous video, 60% of all people who commented on the video want to see a block event length adder. So basically we wanted to see a contraption where you could input a number, like for example this would be 4, and when that contraption would extend the length of a block event pulse that gets in by 4. And that's what I've done. Now the thing I want to focus on in this video is on a different side of block event technology, but I just want to show this in the beginning because of a lot of people wanted that. So right here I have a general block event monostable, and with this setting it will generate a 5 block event pulse because the signal strength is made so that the first 5 rails in here get activated. Then I have a block event adder here, where this is just a block event preserving repeater, so you can ignore this. Then here we have a detector. Now this detector is laid out differently than normal, because if you lay it out normally you can only detect up to 15 block events, because after that the signal strength of the redstone here will run out, but I laid it out differently so it can detect pulses up to 22 block event length. So what I have done right here is I put the extender to a 4 setting and the monostable to a 5 setting. So right now we are generating a 5 block event pulse here, extending it by 4 block events, so that's 9 block events. This one doesn't change it, so right here we should get 9 blocks drop down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and it can add numbers. Now it's so the maximum setting here is 10. That's the maximum I managed to fit into here. If you want more, you can just chain multiple of these adders, and then you can get even higher block event amounts, because and if you can chain an arbitrary amount of these. So right now we have both on the maximum setting. This one can generate at maximum 11 block events. This one can extend by a maximum of 10 block events. So we get 21 block event length, and this detector can detect 22. So everything except one piston fired. So we now have 21 blocks, and that's everything except the last piston, and that was weird. Yeah. Now if you want to use this in larger contraptions, you probably won't directly add levers to the block event adder, but you will probably use another monostable when you can kind of store the length of a block event pulse. So we can send a 5 block event pulse into here, and then 5 of these cauldron will be dropped. And I just noticed that I haven't even explained how this thing works, the adder, yet. So I will probably do that now, and then you have kind of a monostable which extends everything by 5 block events, and then you can use it. So how does this thing work roughly? So, well, basically if those pulse gets turned on, all of these pistons will get butt powered. Down here we have rails, and you can see all of these rails are unpowered, so they will all activate when this pulse turns on, and they will all update these pistons. And this means that this piston will instantly get a block update, and then he will instantly start extending. When he starts extending, the pulse gets through here. Now since this is a chaotic pulse coming out of here, this line will later turn off again. Now the thing to note is that by the time this pulse turns off, these 2 pistons here have extended, and when these 2 pistons extend, then let me quickly extend them. Then that was stupid. Then redstone will get up from down here, because down here we have comparators. This is kind of the input. The cauldrons here are the inputs. Also over here the cauldrons are the input. So the redstone will get up here and power these rails, which means that if the pulse turns off again, all of these pistons will be but unpowered, but these first pistons won't get any block updates. The first piston which will get a block update is this one, because for this one the rail turns off and updates this piston. And when this piston will have a block event, and will eventually retract and update this one. When this one will have a block event, when this one will get a block event, and this way it creates the block event delay and extends the poles, because for turning on it just adds one block event delay, and for turning off it adds multiple block events of delay. And when we have this repeater, and exactly when this one turns off, then he will drop the block over here, and then the poles will be off again. And here we have just a similar, we have just a repeater to extend the length signal strength again for this detector. I compacted it down from the last version. This one works very simple. When the pulse turns on, this one will start extending the block, and when the redstone goes through, and when the pulse turns off again, the piston will drop the block, and then the block will be over here. So that's basically the block event adder, and a lot of people wanted to see this, so I included this. And here I have again the block event preserving repeater, the more compact version. Now what I want to look at in this video are different pulses than just chaotic pulses. So the first thing we will take a look at is chaotic off pulses, which means pulses which turn off and on within the same game tick. Because you can also talk about block event length for these pulses. For example, here I have a monostable which will create a 2 block event chaotic pulse, and then here we have an inverter which will change the chaotic pulse into a chaotic off pulse with the same block event length. So if I flick this lever, 2 of these pistons here will retract, and I will quickly walk you through this one and give you a block event analysis, even though it will probably be quite long. But so you can understand this construction. So these two will get tile ticks, and the repeater will update first, and when the repeater updates he will go over here and schedule a block event here. This comparator will schedule a block event here. Now the tile ticks are finished, so now this piston will extend, and when this piston extends you can see this line turns off. Okay, so this piston will extend, and then it will update this piston, and the piston sees I'm not powered, so I will get a block event so I can retract. So that's something we will do. Next thing that will happen is this piston will extend, and the only thing he does is update this piston down here. Then the next block event is this magenta one. This one will retract and update this piston, so this piston will schedule a block event. And I think I will need more clay for this. Okay. The next block event is this one, and then this one will extend and you will cut the power, which means that this redstone line will turn off again, and then this piston will get another block event to drop the block. So this piston has started extending, but once the green block event gets processed, he will drop the block, and then the pulse will be on again. So basically the concept here is when the piston starts extending, the pulse gets off, and when the piston drops the block, the pulse turns on again. That's basically the idea. Now this block event will get processed, so this piston will also retract, so these two pistons retracted. Now the green block event will be processed, the block will get over here, and then the line will be on again, which means that this piston won't retract anymore. And that's basically the idea, that you can kind of convert a chaotic pulse into a chaotic off pulse. Now of course you can also make a monostable, so this is a chaotic off pulse monostable. I can also walk you through this one, and I won't need much clay for this one. So basically when I turn off the lever, first the repeater will be turned off, then this redstone line will be off, and this one will get a block event. Secondly, this comparator will turn off, and this piston will get a block event. Then this piston will retract and schedule a block event here. And then this piston will retract, and when this piston retracts, the redstone from down here will connect up here and turn everything on again, so this piston won't retract. So here we will get one piston retracting from this chaotic off pulse monostable. What do I have over here? Oh yeah, I wanted to show that this inverter does not only work with 1 or 2 block event pulses, but with any pulse. So I put a general block event monostable over here, and then here we have an inverter. Then we can see that we can retract any amount of pistons we want. So for example, if we put 4 here, then these 4 pistons will retract. So you can see that. And if we put it over here, then all pistons except 1 will retract. So this piston will stay here, and all the other ones will retract and then extend again. So that's basically how this works. Then I also try to make block event preserving repeater for theoretic off pulses, and I mean, this thing works, but this thing is giant and messy, and the problem is if you want to use theoretic off pulses and preserve them, is that you don't have an equivalent for block dropping. I mean, for example, at theoretic pulses I can extend a piston. That's what he's doing when the pulse is turned on. When the pulse is turned off again, when he does the block dropping. While with theoretic off pulses, if the pulse turns off, the piston retracts, and if the pulse turns on again, I get nothing. So it's much more complicated. So if you want to use theoretic off pulses, I would recommend to use theoretic pulses as long as possible, and then invert them. Now you might think that theoretic off pulses are completely useless, and to some degree I guess you're right, but what can be useful again are combined pulses. So what I have here again is this is not a monostable, this just turns pulse on and off. So it's basically just creates a delay from the repeater, but it turns it off on and off in an interesting way, because as you can see this piston here does not extend, even though if you would power it normally he would extend. So if I power this, both of these would extend, but this way won't, and this also is based on block event technology, so I will explain how this one works with the clay analysis. Yeah, I'm using here 3 different repeater priorities. I don't really want to go too in depth about repeater priorities, but basically this one will be put before this one, for this one, and maybe I can link a video where the tactic priorities of this stuff is explained, but it will update in this order. So what this means is that first this one will get processed when this redstone line will turn on. This one will get a block event. The second thing that happens is that this one will get a block event and this one will get a block event. I will probably need way more clay for this. So okay. Now the first block event will get processed, so this piston will extend and it will update this piston over here. So this one will get the fourth block event. Then what happens is this piston extends and the redstone will go up here and this one will get a block event. Now number 3 gets processed, that's this one, and now this line of redstone will get turned off again. And this means that this piston will get a block event to do the theoretic block dropping behavior. But now the fourth block event will get processed, this one, but currently this line of redstone is off, because this piston has retracted and cut the redstone line. So this piston won't extend. And now the last thing we will do is we will make this block event. And with this block event, this redstone line will go up here and turn everything on again. And if everything is on again, then this piston won't do any block dropping, because this piston sees I'm currently extending and the pulse is on, so everything is fine. And then you will get this kind of behavior, when you can kind of manipulate these pistons independently. So we can not only make this piston do a theoretic pulse block dropping, but we can also make him do a normal extension. And if we do this, of course this piston here is budded. But that's kind of interesting. Now we can also do the opposite, that we turn a pulse off, then on and off again, to only manipulate one piston. That's basically like this. So this piston here stays extended no matter what we do. Now this one is a little bit more complicated. Basically what we have here is a theoretic off pulse monostable right here. So we retract the upper piston but not the lower piston, just like the way we did it here. So that we retract the upper piston but not the lower piston. And what we additionally do is that after a very specific delay we turn off this torch, so that the pulse will then be off. And the reason you need a very specific delay is it's kind of hard to explain. Maybe I just walk you through this, because that is the best way for me to explain things, because there I know how to do things. Yeah, but the problem is I will have to get into delay here, because this is not priority stuff but delay. So basically what we have, okay, I had to cut there shortly, but I think that might be good, because now I built up some things to give a better explanation of this thing. To understand this thing, we have to first to analyze the timing of this thing. So we have to look both at the timing and the update order of this thing to understand it. So I will make a quick rundown of the timing. So when we click this lever, these two will do things. This one will turn off at tick 3, this one will turn off at tick 1. They will have one game tick less when we are base delay because of the lever bug. This piston will extend. He will need 2 game ticks to extend, or if you believe in Stankan solid length theory, which I'm not going to talk about, 4 game ticks. This one will finish extending after 6 game ticks, and this touchdown here will finish turning off after 8 game ticks. So that's this line. This is one of the timings we need, and this one we don't need anymore. So this is one of the numbers we need. And up here, this turns off after 3 game ticks, which means this repeater turns off after 5 game ticks after the lever has been flicked. So he has a 2 game tick delay, and this one has also a 2 game tick delay. Now, of course, these are going to do a 1 tick off pulse. So only the upper of these 2 pistons will actually retract, and this one will finish retracting after 7 game ticks. And with this, these are the 2 timing numbers we need, and now we need to look into processing order and piston behavior to understand what's exactly going on, because the difficulty is to turn the pulse off in a way that the piston down here doesn't receive an update. So we now have to look into piston behavior a little bit. What happens when you retract a piston? When you retract a piston, of course, he's going to get a block event. And now what is he going to do up on the block event? He will create something called a block 36. And this block 36 will get processed in every tick. And I just put some categories of the processing order of every tick here. So basically in every tick, first player requests are processed when tile ticks, when block events, when tickable tile entities, and block 36 is a tickable tile entity, and he will get processed in every tick. So he will have initially a progress of 0, when he will have a progress of 0.5, and when he reaches a progress of 1, he will become a normal piston again. And in game tick 7, this piston, which is a block 36 during with its retraction, will become a piston again. And when it becomes a piston again, this pulse will still be on because this torch hasn't turned off yet. So he will schedule a block event. And another thing he will do is he will update this piston down here. This piston is extended in this piston. This pulse will be on. So he will say, I'm fine the way I currently am. So this piston will do nothing, and that's the important part, that this pulse is still on when this piston finishes retracting, but now we need to turn off the pulse before this piston starts extending again. So that's game tick 7. So in game tick 7, tickable tile entities will get processed, and when the block event here will be scheduled, and when the tick will end. And when the next tick will start, tick number 8, we will get player requests and we will get tile ticks. And the redstone torch is a tile tick, so the redstone torch will then turn off. After the redstone torch, block events will get processed, and when this block event will get processed, and then this pulse will be off, which means that this piston won't start extending again. And this piston won't do anything because you didn't receive any updates anymore. So that's basically how this works. This is a very quick rundown. I had to go over many different things which I actually didn't want to go over because I wanted to keep these kinds of videos to something that you can understand, but I now had to go into several things you need to keep in mind. I will link link to the full processing order because it's really useful to understand things. It's sometimes required to understand things. Because what you saw, for example, here is this piston got his block event in tick number 7, but the block event was processed in tick number 8 because he got this block event here, and the next time the block events get processed is only in the next tick. So it's also something you need to keep in mind sometimes. Anyway, now let's continue on. Here we have the same again, except that we use a theoretic of pulse which retracts two pistons. And everything is exactly the same as over here. Because when we turn the pulse off at the same time and have the same thing with the torch and the pistons, except that we initially retract two of the pistons and only two of the pistons stay here. And the last thing which I want to show in this video is I hooked up I have a general theoretic pulse generator, and then here we have an inverter, and I put an inverter into this position where this torch gets turned off at the correct timing, so we can manipulate these pistons over there. So for example, if I do this, then we will generate a theoretic pulse of 4 block event length. We will invert it, so we will get a theoretic off pulse of 4 block event length. So 4 of the pistons will retract, the rest will stay. And then we will turn off this torch at exact timing, so that all of these other will stay extended while these will stay retracted once they finish retracting. So it would look like this. So you cannot only give them a theoretic off pulse so that only a few pistons get them. You can really turn off and on the line so that only a part of the piston reacts to the pulse. So that's basically the last thing which I wanted to show in this video. Bye.